Thank you, Angelo. Really happy to be here, and thank you everyone on site as well. It's a pleasure to meet you in person. For some of you, I've been working for a while with you, so it's great to be able to chat in person. All right, so essentially in this presentation, I am making the case for Edge Native and Zenoh together, and I wish I would have the time to inject my little dose of usual humor there, maybe a few slides with funny pictures of love and things like that. I didn't have the time. So this is a serious presentation, but if there's one thing you should remember about it, it's that really Zenoh and Edge Native are really a perfect fit together. And as you will see, I will skip quickly over some elements that Angelo already covered in his presentation. But really what I'm trying to make the case is really, okay, we'll try to understand together what Edge Native is, and then we'll see how Zenoh perfectly fits into the Edge Native model. Okay, so to understand Edge Native, you first need to understand what the cloud is. And why is that? Well, because the Edge is literally the opposite of the cloud. Okay, so when we talk about cloud and cloud native applications, we're talking about an environment where essentially resources are available on demand, and they are nearly limitless. Not limitless. I have a friend somewhere in Germany that completely exhausted a specific VM type on a large-scale cloud provider at some point, so there weren't any, not even a single additional of that VM type available in that particular region of the world because of that guy. So that's hundreds of thousands of VMs. Don't ask me what he was doing with this. But anyway, and the fact is, with the cloud, the resources are homogeneous. So you know that you have those VM types, you have those networking resources that you deploy. They are all the same. You can configure them, but their basic characteristics are the same. It's a large-scale environment most of the time, unless you're dealing with a smaller cloud provider. But in most cases, you have plenty of resources to tap from. And it's centralized. Have this central console you connect to, and then you provision the stuff. The Edge is completely the opposite of that because it's completely distributed. You are putting devices in the wild. So an Edge node on every bus in Paris, an Edge node on every locomotive from Deutsche Bahn, whatever you may think about it. This infrastructure is the place. Okay, the Edge is literally anywhere and everywhere at the same time. That's really important. And typically, Edge is at small scale. Unless you have unlimited budget, you will try to right-size your hardware that you are putting in the wild, right? You will pick a power-efficient processor that will be up to the task, but trying to, since you're deploying this, at a small scale locally, but in most cases, you will deploy hundreds and thousands of those nodes. You're trying to be as cost efficient as possible, right? And finally, they're heterogeneous. Why? Because essentially, you are trying to pick the right hardware for the job. So in some cases, you will deploy hardware with an AI accelerator because you will be analyzing video on the fly, okay? But this is costly, so none of your Edge nodes will have that. And at the same time, you want a framework, a protocol that work with all of those types of nodes, right? And to keep in mind how heterogeneous the environment is really, really important. All right, so now, if we take a step back and try to define what edge computing is, it's literally about putting computing storage as close as possible to the source of the data, or the point in the real world where you will interact with the real world, right? You will have an actuator that will do something. So that's where you want to be. And that's why there's not one edge, two edges, three edges, telco edge, and this edge, and that edge, right? Some people are trying to count them or whatever, but really the edge is really something that is anywhere and everywhere. And so in contrasting, once again, Edge native and cloud native, when we think about cloud native, we say that we use DevOps, Agile, things like that. We do microservices, we put them in containers, and this is from my Pivotal days, but you repair, repave, rotate. So an individual container is not that important because if you have to deploy an update, then maybe you just kill it and deploy another, right? That's the cloud mentality, really. At the edge, you wouldn't do that if we think about the kind of use cases we have in Edge. Let's say you control a nuclear power plant or something. Well, obviously you don't want to kill that container because you would kill a few 100,000 people around it, okay? So Edge is pretty much about mission critical use cases in real time, and that's a whole different ballgame that, oh yes, I will refresh my browser and get new features in my Google Doc, right? That's great, but Edge requires from us a certain level of carefulness, I would say. So, but there's more than that, right? Typically, if we think about old-style IoT projects, oh, but you know, this microcontroller, a robot like we'll see, you know, in news this morning, it's great. I connect that to the cloud. It's easy, it's performant, and all of that. The problem is that when you do that, you are facing a number of challenges, and those challenges, edge computing helps you overcome them. For example, latency. Okay, it's great that I can control, you know, an oil and gas or a bus using, or even monitor them using IoT, microcontrollers, and sensors. But there's the latency to the internet is not stable, it's not predictable, okay? And that's really a big problem, because if you think about it, if I need to send this real-time data flow to the internet and all the way back my decision, maybe everyone on the bus is dead by the time I get back my decision from the AI in the cloud, right? So you want to closer to the source of the action, and that's why edge computing is such a tool in addressing latency. There's the problem of bandwidth. AI video analytics, but if you need to send, let's say, just a full HD video to the cloud, it will be roughly 5 to 3 gigabytes per hour, okay, that you will consume in bandwidth for transmitting a full HD for 1 hour. And that's even with compression, optimizations, and that. So obviously your telco operator, if you do that, will be happy, but you won't be. We don't want to happen. So edge computing means that you move the AI at the edge. Then there's the risky aspect, right? In many mission critical real-time cases, you want the infrastructure to be as robust as possible. And then obviously by having this infrastructure locally, you are more resilient. And there's the whole aspect of data sovereignty. If you don't, in many industries, like healthcare, defense, you don't want the data or even the business logic to go outside a specific physical location, okay? Or I was an video at one point, we had air gap environments where we needed to deploy stuff. So once again, cloud is not an option there. So what do? Well, you have edge nodes, and then you can preserve this data sovereignty aspect, where you ensure that, let's say, the student data wouldn't leave this university campus, the patient data wouldn't leave the physical location of the hospital, or maybe of a specific region or country, or even the territory of the European Union. Whatever you have in mind in terms of regulation, edge is certainly a powerful ally in this. Anyway, by the way, we've been talking about edge a lot. One important thing to remember about edge computing is that edge computing projects are not typical IT projects. Okay? If you're putting sensors and edge nodes all over the place, you know, on every bus and subway train, in, for example, you don't want to rip that off every 2 months, right? You are deploying for the so you need to think about the lifespan. It's heterogeneous, as we mentioned, and there are specific constraints that you need to address: the power consumption, the bandwidth limitations, interference, humidity, dust, cold, etc. Okay, so all of those things are things that typically you don't think about in the cloud, because your servers are in a magical data center that is administered for you. And then the connectivity aspect, right? You do edge computing, there's a network, but you have to assume that it won't be reliable. You have to assume that bandwidth will degrade at random times, and you need to design around this. Now you can, as a developer, do that all of your own, or you can rely on protocols and infrastructure that will take care of some of those problems you. And this is where Zenoh is so powerful. Also, there are very, very, very specific things to keep in mind when you think about edge. The network situation, I already addressed it. The network will degrade, it will fail at random times. And you know, the emphasis is pretty much on optimizing for size and power. Even if you have plentiful resources, you want to optimize for size and power because essentially you never know where you will need to do something else on that node, right? So if you optimize today, you keep more future resources for future use. And that's really important because once again, there's no way you will rip off all of those edge nodes every 2 years to upgrade them and get more memory. So being thrifty as you develop is something really important, right? And then there's the whole situation with zero trust, where essentially when you're doing edge, you don't want by default to trust any single device. And why you're doing that? Well, you're doing that because you never know when a device could be compromised. So out of the box, you need to be distrustful, not in your personal relationship, but you know, any node that leaves the confine of your office or of your campus, whatever, is something that you should be treating very carefully. And there are many ways to address this, but certainly, once again, Zenoh is an interesting ingredient, so to speak, in a recipe for zero trust computing. So you would say I'm doing edge computing, of choices in terms already of protocols. So would I need Zenoh? Well, the thing is, when you look at those existing protocols, some of them are client response, some client server, some of them are peer-to-peer. And Angelo highlighted this around DDS already, but yes, you have plenty of options, but when you look at them, and we have plenty of implementations for them at the Eclipse Foundation, right? So if you are interested in those, we have projects for you, right? But our focus is really on Zenoh today, because each of those has a little thing that makes it not the best choice necessarily for edge computing. In terms of CoAP, for example, you have longer transmission times, and DTLS as an encryption technology has its limitations. In the case of DDS, well, I mean, Angelo has been through integration hell already. I mean, he could tell you interesting stories about that. The fact is, even though there's a spec and a standard, most of the time it's difficult to interoperate between vendors in the DDS ecosystem. And then trying to out that traffic over the public internet is a nightmare. LightOM is tied to CoAP and UDP, so it shares the weaknesses of CoAP. In the case of OPC UA, things with OPC UA, it's all over the place. And the problem with it, you know, have you seen those specs? They are full of complicated diagrams. Well, the DS spec is the same, right? You ask someone who is married to a class diagram design a protocol, and that's what you get. I mean, okay, they are more intelligent than me, but then I don't have the time to be intelligent when I need to deliver a project. So keep it simple, okay? So the problem with OPC UA is literally the complexity. So many profiles, so many things to take into account. 1,600 pages plus of specs to implement for implementers. Well, that's complicated. And then the MQTT, it's great, right? And it's certainly mature and widespread in adoption, but it's tied to UDP, and you can do MQTT over UDP with SN, but MQTT SN is literally a different protocol that's using some of the same blocks. So it works, it can interoperate up to a bit. You have now to manage two different standards depending on the environment you are working with, and that's not ideal. So why is Zenoh so important and so relevant to edge computing? Well, to understand that, you have to remember what the actual journey of data. Most protocols will care about step 2, transmission, sorry, right? So you capture something and then you use the protocol to transmit, and that's all. You know, that's all the protocol cares about. Zenoh goes the extra mile by taking into account computations, storage, and retrieval down the road in an integrated fashion. And that's literally the opportunity it capitalizes on. And those functions, you know, provide computations, doing local storage, retrieve information are literally what makes edge native different from the typical device to cloud environment, okay? And to come back to that point, this edge environment, when we say there isn't one edge, there are multiple edges, okay, that's what you see in this diagram extracted from our white paper on EdgeOps that we published with the help of the Zscaler team, with the help of the Zenoh team here, right? You have components for your applications that are all over the place on the physical spectrum, starting with the local physical environment, transport layer, regional infrastructure, all the way up to the global cloud, okay? And your applications and your edge nodes will be all over the place through that continuum, and Zenoh is a way, certainly, to implement it in that way. And we've seen with Angelo what Zenoh is, and you can see early adopters on the slide, people that have already evaluating or even directly working with the technology. And we've seen already this and that, but really the one thing that you need to realize is really the flexible Zenoh is, and the fact that you have client nodes that can be constrained, low power, you know, just wake up to sleep, set a value, go back to sleep for 15 minutes and things like that works well. And then you can have those peer-to-peer networks, those routes that tie everything together. It's great. And of particular interest, obviously, is the Zenoh Pico implementation, is the library targeted at constrained devices with zip port and all of that. It's certainly something interesting. So I have an example there, but we have local nodes, you know, that will illustrate this better. But really, what is interesting in that particular diagram is really the geographical distribution. So this is an extract. So you're the first in the world, apart from Angela, saying this. So I'm writing a book. I wrote a chapter on Zenoh, and the little example I give in the book, and you see of robots who would be distributed in Canada and in France, and in this centralized and yet decentralized fashion. And you know, it's not just a pipe dream. It's literally something that you could implement because of the features of the protocol. So with the proper nodes in the proper places, you can make something like that happen really in the real world. And then you can have those distributed databases. You know, you see at the top in France, one at the bottom in Canada, recording local data for local consumption or even for compliance with local regulations. Okay, so it's that easy to implement because the protocol has been built, found from the ground up to cover cases like that with everything is massively distributed. Okay, so all of this sweet Zenoh action is happening at the Eclipse Edge Native Working Group. If you are not familiar with Eclipse, or if you think that Eclipse is just that old IDE that you hate, you are free to hate it, right? I don't judge. Personally, I feel it's perfectly fine, but if you want to use something else, that's fine. But that's one of the 420 plus open source projects that we have, and Zenoh is one of those 420. So please, just because we have an IDE you don't like, we have plenty of other technologies there. The Edge Native Working Group is really focused code first, which is we build actual platforms rather than abstract architectures, and then we derive architectures and best practices from the real world work that the Zenoh team is doing and the other projects that we have as well. And the whole point is to deliver what we call EdgeOps. And what EdgeOps is literally taking DevOps, which is great, but you know, bringing it to the next level so that it makes sense at the edge. And that means addressing the challenges of the edge: latency, bandwidth, resiliency, data sovereignty, taking into characteristics the solutions of edge computing deployments, and you know, keeping in mind the types of deployments that you do at the edge as well. So that's DevOps, but DevOps which is really a good fit at the edge, because the last thing that you want is to patch every car on the périphérique around Paris at 4 p.m. in the afternoon. You don't do that. So doing naive DevOps, plain DevOps at the edge would be dangerous. we do EdgeOps instead, and Zenoh is certainly a premium implementation of the EdgeOps concepts that we described in this white paper that we published last year. So Luca from Zetascale has been a big contributor to that paper. You know, it's 1 year old, but it's still pretty much relevant, and even more than when we published it, because essentially the way that the edge computing industry is headed is literally what we describe in this paper. So you have a download link, you have a QR code, you can have if you are interested. And really, as the conclusion, you know, Zenoh is one part of what you need to build a full edge computing ecosystem, right? So the logos that you see in color here in this little matrix, which is part of the white paper, are Eclipse projects. And then you have in grayed out other components that we care about, you know, in the wider scale. And we tried to put them on the edge to cloud continuum, on the development to operations continuum. As an approximation, yes, of course, you could have Kubernetes on an edge node if you are crazy and want to waste resources, for example. I'm not judging. Anyway, you can do it. The point of the matrix is just to try to pinpoint them in a space to position them compared to one another. And you see at the bottom, that's the old version of the logo, sorry. But you see which is really so close to the edge and so close to the development angle. And then you have all of those other components at Eclipse that you can rely on in order to build robust edge infrastructure. So when you look at the current membership of our Edge Native Working Group, what you realize is that, well, there's one logo missing, and it's yours. So we are open for business, open for collaboration, and looking forward, especially if you are a Zenoh adopter, someone who believes in the technology, please join us in this effort to build reliable open source edge computing infrastructure. So thank you so much. Really appreciate your attention.